Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Lens by Doc Logic, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have thermometers, where digits increase starting from the bulb. So, for example, you could have something like, say, 2, 3, 5, 9 here. And this would be valid because it's increasing from going from the bulb to the tip. An example of an invalid thermometer would be something like 2259, because these digits are not increasing from this cell to this cell, going from the bulb to the tip on the thermometer. So that's an example of how thermometers work. And we have killer cage, where the 5 digits in the cage must sum to 25. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. Let's go here. Along this thermometer, and this is what I like to do with particularly long thermometers, is I like to go from the bulb to the tip, looking at the smallest digit possible for each cell, and then going from the tip back to the bulb, looking at the largest digit possible. So let's try that. So say we had one, this could be 1 here, because that's the smallest digit in Sudoku, in normal Sudoku. This digit has to be at least 2, because it must be greater than 1. That means we have to have 3 here, at minimum 4, 5, 6, 7, or 8. So these are the minimum values for those cells. Now let's look at the maximum values for these cells. This has to be at most 9. This must be at most 8, 7, 6, 5, 4, 3, and 2. Okay. So the question we have is, what happens if this is 3? If this is 3, this has to be 4, 5, 6, 7, 8, 9 here, because those are the only digits which are going to be greater than 3 along the thermometer. But the problem is 3 plus 5 plus 7 plus 9, that adds up to 24. And 44, which is the sum of the digits from 1 through 9, which is for every box, or every row, or every column, 45 minus 24 is only 21. And that would basically eliminate all possibilities for this cage, because it can't add up, it has to add up to 25 here. Therefore, these 4 digits must add up to 45 minus 25, which is 20. And that's only possible if this is 8, this is 6, this is 4, and that's 2. That adds up to 20 there, and that's the minimum possible for this thermometer here. So this must then be 2, 4, 6, and 8, which leaves the remaining digits on the thermometer as 7, 5, 3, and 1. So the remaining digits in this central cross here have to be 1, 3, 5, 7, 9, and these can't be 1 or 5 because a 1 or 5 of the column, so this must be a 1, 5 pair here. These can't be 3 or 7 because of the 3, 7 pair in the row, so this must be 3 and 7 here, which leaves this as a 9. Now that's interesting. That means we have in column 5 and in row 5, we have all the odd digits accounted for. And these are all even here. Which means the rest of column 5 and row 5 have to be even. So these are even and these are even. Okay. Let's look at this thermometer. It's pretty long. So we'll start at 1. This can be 2. This cannot be 3 because of 3 in the box. So this is 4 at minimum. 5, 6, 7, 8. And those are the minimum digits going from the bulb to the tip. Looking back from the tip to the bulb, this is 9, this is less than that, so it's 8, 7, 6, 5, 4. This can't be 3 because of 3 in the box, and it can't be 2 because of 2 in the row, so this has to be 1 here. So this is 2 or 4, 4 or 5, 5, 6, 6, 7, 7, 8, 8, 9 as possibilities. Another thing you know about these normal thermometers is where can 1 and 9 be on these normal thermometers? Well, they cannot be, 1 can only be on a bulb, and 9 can only be on a tip. Well, in this left central box, every digit is on a thermometer, but where are the tips and where are the bulbs? Well, we have a bulb here, so that's 1 there. And we know that's 1 because of the way that this thermometer works. But where are the tips? The only tip available in this left central box is here, which must be a 9. So that's 9. And in this right central box, we have a similar situation. Actually, we have in this upper central box and this lower central box, also the situations like that, where every cell in the box is on a thermometer. So we need to look for tips and bulbs. Well, bulbs are here, but we can't have a 1 there because of 1 in the row, and this is the only bulb left, so this must be 1. And tips are 1, 2, and 3, but these can't be tips. These cannot be 9s because of 9s in the row, so the only tip left is here, so that's a 9. So let's look at this upper central box. Well, we don't have that as much information. Let's look at this lower central box. We already have the 1 in the box, so for the tips, where are the tips in this box? It can only be here. That eliminates 9 in the rest of the column here. So in column 6, where are the tips? The only tip actually is here. So this is guaranteed to be a 9. So these are odd digits. Where is 9 in this right upper right box? Cannot be here or here because of 9 in the column and row. Can't be on non-tips, so it has to be one of these 2 digits here. Where is 9 in this lower right-hand box? Cannot be here and here because of 9s in the row and the column. Can't be here because of 9 guaranteed in one of these 2 cells for that box, so it has to be one of these 2. How about this upper left-hand box? Cannot be here or here. These are non-tips, so 9 has to be one of those 2. This is 1 and is odd. 9 can't be here or here, so it could be one of those 2. Okay. This digit has 2 digits smaller than it. So it cannot be 2. So it must be 4, 6, or 8 here. Same with this cell here. It's 4, 6, or 8. This digit also has 2 digits smaller than it. So that's 4, 6, or 8. Same with this. This has 2 digits smaller than it, so it's 4, 6, or 8. Well, this digit has 1 digit smaller than it, but it can't be a 1 here. So this cannot be 2 here, because if that's 2, that would guarantee a 1's there, but we already have a 1 in the box. So this has to be 4, 6, or 8, which means where is the 2 in column 5? It has to be here, and the digit smaller than it must be a 1. So that's 1 there, which means this can't be 1 here. It's 5, which makes that 1 there. This is odd. Where can the 2 be in column 6? Can't be here because of 2 in the box. This can't be 2 because this can't be 1 because of 1 in the row. And this can't be 2 because it's greater than 2 other digits. So 2 then has to be here in column 6, which is even. This is 4, 6, or 8. This digit has to be less than 2 other digits, so this can't be 8 here. Remaining digits of column 6. We have 3, 4, 5, and 7. Okay. This digit has to be greater than that, so 3 can't be there. And it can't be 4 either, so this is 5 or 7 there. This digit has to be, these can't be 5 because of 5 in the box. So this digit is smaller than this one, so this is 4 at minimum, which means this can't be 4, it's 6 or 8. This must be less than that, so it's 7. It can't be 7 though because of 7 in the column. Can't be 4, 6. This has to be a 5. That eliminates 7 here because this must be less than 5. So 5 is odd there. This digit is smaller than that, so it has to be at least, at most 7 and at least 3. There's no 4 or 5 here because of 4 or 5 in the box and column. It could be 6 here, though. So this digit is smaller than that. It could be 2 up to 6, but it can't be 6 or 5 or 4 because of 5, 6, 5, or 4 in the row, so this is 2 or 3. It should be less than that. Similarly here, this must be smaller than that, but it can't, 3 eliminates 3 here. So this is 2, which means this can't be 2, that's 4. This can't be 4 then. Where is the 2 then remaining in row 5? It has to be here. So this is 2, this is 2. 4 eliminates 4 here, so that's 5, 6, 7, 8, and 9. That eliminates 9 in the rest of the row, so this can't be 9, which leaves this as a 9 remaining. 9 eliminates 9 here, so the 9 in this upper left-hand box has to be there. That eliminates 9 here, so 9 has to be there in the upper right-hand box. Okay, 8 eliminates 8 in the rest of this lower central box. We have a 4, 6 pair, which eliminates 4, 6 in the rest of the box and column. So no 4 or 6 here, it's 8. No 4 or 6 here, it's 3, 5, or 7. No 5 here because of 5 in the column. Remaining digits here can be 3, 6, or 7 left. This digit must be greater than all of these, so this is 6 at most here. That means 5 at most there, that means 4 at most there. And the smallest numbers can't be 1 because of 1 in the column, so it's 2. Can't be 3 because of 3 in the column, 4, 5, and this must be greater than that, so it cannot be 3, so it's 6 or 7 there. This digit must be greater than that, so we could have at minimum 4, this is greater than that, cannot be 5, 6, or 7 here, so this has to actually be an 8. And this must be smaller than 8, so it's at most 7 here, but it can't be 7 because of 7 in the column. So it's 4, 6. This is smaller than that digit, so it can't be 7. This is the 3, 4 pair in column 6, which eliminates 3, 4 in the rest of the column and box. So no 3 here. 3, 4 eliminates 3 here. This is smaller than that, so it cannot be 7 here, actually. So this must be 6, this must be 5, which makes this 4 and 7 there. 7 eliminates 7 here, so it's 3. Um, these digits, 6 eliminates 6 here, so that's 8, which makes that not 8, so that's 6. Remaining digits in this left central box are 6 and 7. This can't be 7 because of 7 in the column, so that's 6, which makes that 7. 7 eliminates 7 here, so it's 3 and 7 there. This digit must be greater than 7, but it cannot be 9 because of 9 in the column, so this must be 8. Remaining digits of row 6 are 3 and 4. This digit must be greater than that, so it's at least 4. This digit must be greater than that, but it cannot be 5 or 6, which means it has to be at least 7, and this must be greater than that, but it can't be 9. So it has to be an 8, which makes this 7. This is greater than that, so it has to be 4, which makes that 3, which makes that a 4. 4 eliminates 4 here, so that's 6. 6 eliminates 6 here, so it's 7. 7 eliminates 7 here, so it's 6. Which means this is less than that, so it's 5, 4, and 2. 4 eliminates 4 here, so that's 3 and 4. And the rest is just normal Sudoku. So, how do we figure that out? Remaining digits of row 7 are 2. Remaining digits of row 3 are 1 and 3. This can't be 1 because of 1 in the column, so that's 3 and that's 1 there. The remaining digit of column 3 is a 1. Remaining digits of column 2 are 3, 4, and 5. No 4 or 5 here, so that's 3, which makes this a 4, 5 pair. This can't be 4 because of 4 in the row, so that's 5, which makes that 4. Remaining digits of row 8 are 1, 5, and 1, 3, and 5. This can't be 1 or 3 because of 1 or 3 in the column, so it's 5. This can't be 3 or 5 because of 3 in the column, 5 in the row, so that's 1, which leaves this as a 3. Remaining digits of column 1, more specifically, actually, remaining digits of this lower left-hand box is an 8. Remaining digits of column 1, then, are 6 and 7. This can't be 6 because of 6 in the row, so that's 7, which makes that 6. Remaining digits of row 1 now. We have 1, 4, and 8. This can't be 1 or 8 because of 1 or 8 in the column, so that's 4. This can't be 1 because, or 1 or 4 because of 1 or 4 in the column, so that's 8, which makes that 1. Remaining digits of row 2. We have 2, 5, and 7. No 5 or 7 here because of 5 or 7 in the column, so that's 2. That makes that 7 because of the 2, 5 in the column, which makes that 5. And the remaining digits in column 7 are a 3, in column 8 is a 2, and in column 9 is a 6. And that's how you solve it. Yep, relatively straightforward. I try to find different ways of solving these thermometers, but I just keep coming back to it because it's a very useful technique. It works really well at eliminating possibilities. So, but every time I can, I'll try to basically go away from using that. But if it seems the most obvious way to do things, then I'll just default to that. Because I mean, the thing is, why remove tools from your ability to solve things? I'm just always sort of looking for new things that I can find out about, like old rules, but. I don't know. Thermos do seem pretty. There's a very you have certain deductions about thermos which make it easier to solve if you go about it in certain ways. So I don't know how many new techniques I'll be able to find by doing that, by looking for other techniques, because usually the best ones are the best ones, right? They're the tried and true ones. They're the ones that limit things the most. So anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.